Students, we are discussing microbes in a sewage treatment. Microbes in sewage treatment. This microbes in sewage treatment is carried out in two steps, right? Primary treatment and secondary treatment. What and what? Primary treatment and secondary treatment. Now go for some important statements concerned to write microbes in sewage treatment. Note. Number 1, filtration. What is the process? Filtration. Filtration frees sewage from floating debris, right? Floating debris. Filtration frees the sewage from what, sir? Floating debris, right? Number 2, sedimentation. What it is? Sedimentation. Sedimentation frees sewage from what, sir? Particles. From what? Particles. This filtration and sedimentation, these two comes under which treatment, sir? They comes under primary treatment. Therefore, which treatment it is? Primary treatment. Primary treatment includes what and what? Filtration and sedimentation, right? Filtration and sedimentation, they comes under which treatment? Primary treatment. They comes under primary treatment. Next, number 4, sewage which is free from floating debris. Sewage which is free from floating debris, right? And particles. And what? Particles. What it is called as a effluent. What it is called as a effluent. We got this effluent. Where we got this effluent? We got this effluent in a sedimentation tank. We got effluent in what? Sedimentation tank. Therefore, effluent. Effluent produced in which tank, sir? Effluent is produced in sedimentation tank. We got this effluent in which tank, sir? Sedimentation tank. Now this effluent, what we got in sedimentation tank, right? This effluent enters into large aeration tank. Yes or no? Therefore, effluent produced in sedimentation tank, right, taken into what, sir? Large aeration tank. Taken into large aeration tank, right? This is during which treatment, sir? This is during secondary treatment. During which treatment? Secondary treatment. Therefore, during secondary treatment, we are taking this effluent into large aeration tank. Is this statement okay? Right. Next, number 6. We are discussing, right, some important statements concerned to what? Microbes in sewage treatment, right? Next, number 6. Flocks. Sir, what is the meaning of flocks, sir? Flocks means nothing but a mesh of which mycelium? Fungal mycelium. What is the meaning of mycelium? The body of fungi is called as mycelium, right? Body of fungi is called as a mycelium. Therefore, flocks means a mesh of fungal mycelium in which water trapped aerobic bacteria What are trapped? Aerobic bacteria trapped. Is it okay? Right. Next, number 7. Where these flocks are formed? Flocks formed in large aeration tank. Flocks are formed in what? Large aeration tank. Number 8. In large aeration tank, what happens, sir? Oxidation of organic matter present in effluent. Yes or no? Right? Therefore, in a large aeration tank, right, which bacteria? Aerobic bacteria, what it does? Oxidizes organic matter present in effluent. Oxidizes what, sir? Organic matter present in effluent. Aerobic bacteria, it is oxidizing what? Organic matter present in a effluent. So automatically amount of organic matter in the effluent decreases. So BOD value decreases. Therefore, in large aeration tank, in what? Large aeration tank. In large aeration tank, right, what decreases? BOD value of effluent. BOD value of effluent decreases. What decreases? BOD value of the effluent decreases in large aeration tank. Is it okay? Once its BOD value gets reduced, we are taking that effluent into what, sir? Settling tank. Next, number 10. Once BOD value of effluent, decreases, once BOD value of effluent decreases, effluent taken into what, sir? Settling tanks. Effluent taken into what? Settling tank. Is it okay? Right? Next, number 11. All these statements we already discussed yesterday. Once again, I am making a note of all important statements. Right? Next, number 11. In settling tanks, what happens, sir? In settling tanks, right, flocks. What? Flocks settled. What gets settled? Flocks gets settled. Next, number 12. Once effluent becomes free from what? Flocks. Effluent released from where effluent is released? Effluent is released from settling tanks into what? Into natural water bodies. I already told you, once effluent becomes free from what, sir? Flocks. Effluent is released into natural water bodies. From where this effluent is released into the natural water bodies? From settling tanks. Is this statement okay? Right. Next, number 13. This settled flocks. Settled flocks called as what? Activated sludge. What it is called as? Activated sludge. Activated sludge. Sir, this sludge is produced during which treatment, sir? Secondary treatment. So we are calling it as a which sludge, sir? Secondary sludge. Which sludge it is? A secondary sludge. Whereas we got right sludge during primary treatment also. Yes or no? Sludge of which treatment, sir? Primary treatment. Sludge of primary treatment. What we call it as primary sludge. What we call as primary sludge. Primary sludge is also called as what? Grit. Also called as what? Grit. Therefore, primary sludge is also called as what? Grit. Is it okay? Right. Next, number 15. Sir, what happens to this activated sludge, sir? What happens to this activated sludge? That is settled flocks. Activated sludge. Nothing but what? Settled flocks. In this activated sludge, small amount, large amount or small amount? Small amount is introduced. Small amount is introduced into what? Into aeration tank. Into which tank? Aeration tank as inoculum. As what, sir? Inoculum. Whereas a large amount, still it is having large amount of what? Activated sludge. Yes or no? This large amount large amount is taken into what? Anaerobic sludge digester. Anaerobic what? Anaerobic sludge digester. Anaerobic sludge digester. Large amount is taken into anaerobic sludge digester, whereas small amount is introduced into aeration tank as a inoculum, right? Next, number 16. In anaerobic sludge digester, name itself indicate. In anaerobic sludge digester, what gets digested? Activated sludge. Activated sludge gets digested by which bacteria? Anaerobic bacteria. Be careful, it is which bacteria? Anaerobic bacteria. Is it okay? During this digestion, what is produced? Methane is produced. Therefore, in anaerobic sludge digester, activated sludge digested by anaerobic bacteria and produces what, sir? Produces methane, carbon dioxide and hydrogen sulfide. These three together forms which gas, sir? Biogas. These three together forms which gas? Biogas. What and what forming biogas? Methane, carbon dioxide and what? Hydrogen sulfide. Now you see, in the total process of sewage treatment, two steps are involved, I told. What and what? Primary treatment and secondary treatment. Yes or no? What and what? Primary treatment and secondary treatment. In primary treatment, no microorganism is involved. Therefore, primary treatment is biological or abiological? Primary treatment is abiological. Primary treatment. Primary treatment is what, sir? Abiological. Primary treatment is abiological. Whereas secondary treatment is what, sir? Biological. secondary treatment is what, sir? Biological. Primary treatment is abiological, whereas secondary treatment is a biological. Sir, in sewage treatment, which microorganisms came first? Aerobic bacteria. Then only what, sir? Anaerobic bacteria. Therefore, role of aerobic bacteria came first. Then only the role of what, sir? Anaerobic bacteria. Therefore, in sewage treatment, what, sir? Treatment. In sewage treatment, write role of which bacteria? Aerobic bacteria, followed by a role of anaerobic bacteria. Sir, how we are saying this statement, sir? Because aerobic bacteria showed its role, right, in which tank? Large aeration tank. Yes or no? Large aeration tank. Large aeration tank. Whereas the role of anaerobic bacteria, we saw this role where, sir? In anaerobic sludge digester, right? In what? Anaerobic what? Sludge digester. In anaerobic sludge digester, right? Next, number 19. Sir, where this biogas is produced? Right, in anaerobic sludge digester. In anaerobic sludge what? Digester. What is produced? Biogas produced. Sir, what is the use of this biogas? Biogas is a source of energy, right? Biogas is a what? Source of energy. Who is source of energy here? Biogas is a source of energy, right? Number 2, biogas is a inflammable. Who is inflammable? Biogas is inflammable. What is the meaning of inflammable? Catches fire easily. What is the meaning of inflammable? Catches fire easily. What is the meaning of inflammable? Catches fire easily. Therefore, biogas catches fire easily. Is this statement okay? Right? Now, listen this statement. Due to urbanization. Due to what? Urbanization. Due to urbanization, right, large quantities of sewage are generated. What are generated? Large quantities of sewage are generated. Due to urbanization, due to what? Urbanization, large quantities of sewage, large quantities of sewage generated. Sir, sewage leads to pollution, yes or no? Therefore, without treating the sewage, we cannot release them into the water bodies. But what is happening means, as large quantities of sewage is generated, to treat this large quantities of sewage, more number of sewage treatment plants are required, yes or no? To treat this large quantities of sewage, more number of sewage treatment plants are required, but we are having less number of sewage treatment plants. That's why large quantities of sewage without treating, it means untreated sewage is released into the water bodies. What is released? Untreated sewage is released into the water bodies. Therefore, due to urbanization, large quantities of sewage are generated. As number of sewage treatment plants. I already told you STP, right? Sewage treatment plant, right? As number of sewage treatment plants are less, most of the sewage released into what, sir? Water bodies. Released into water bodies with treatment or without treatment? Without treatment. Without treatment, which leads to pollution. Which leads to what? Pollution, and which leads to waterborne diseases. Sir, what is the meaning of waterborne diseases, sir? The diseases which spread through water. Diseases which spreads through water. Such diseases are called as waterborne diseases. Therefore, as sewage untreated released into natural water bodies, it is leading to pollution, as well as it is leading to what? Waterborne diseases. Leading to waterborne diseases. That's why our Indian government, what it did means, Ministry of Environment and Forest in India, a department by name Ministry of Environment and Forest, right? This department, right, it has established two plans. In India, Ministry of Environment and Forestry introduced what, sir? Number 1, Ganga Action Plan, and number 2, Yamuna Action Plan. Who introduced these two? Ministry of Environment and Forest, or Ministry of Environment and Forestry of Indian government introduced Ganga Action Plan and Yamuna Action Plan. What are the main aims of these two plans, sir? Right, their aim is to construct more number of what? Sewage treatment plants. More number of what, sir? Sewage treatment plants. If more number of sewage treatment plants are constructed, automatically what happens, sir? If more number of sewage treatment plants are constructed, automatically, right, more quantities of sewage will be treated. More quantities of sewage will be treated. Right, 22. If wastewater want to be used for domestic purpose, then we have to do tertiary treatment. Which treatment? Tertiary treatment. Sir, when this tertiary treatment is done, sir, if wastewater want to be used for which purpose? Domestic purpose. If wastewater want to be used for domestic purpose, then we have to do which treatment, sir? Tertiary treatment. Is this statement okay? Right, sir, tertiary treatment is a physico-chemical process. It is a physico-chemical process. It is a physico-chemical process. Sir, in tertiary treatment, what are used, sir? Tertiary treatment uses number 1 chlorine, number 2 ozone gas. Which gas? Ozone gas. Number 3 reverse osmosis. What, sir? Reverse osmosis. UV rays. Sir, why we are using all these, sir? Chlorine, ozone gas, reverse osmosis, UV rays, to remove DDT, pesticides, pathogens, and turbidity. What? Turbidity of wastewater. Turbidity of wastewater. See these statements carefully. When we are using tertiary treatment, if we want to use wastewater for domestic purpose, then we are using this tertiary treatment. Tertiary treatment, we are not exploiting a microorganism, so it is not biological. Then how we are doing this tertiary treatment, sir? We are doing this tertiary treatment by using chlorine gas, ozone gas, reverse osmosis, right, UV rays. Why? To remove DDT, pesticides, pathogens, and turbidity of wastewater. So this tertiary treatment is a which process? It is a physico-chemical process. Tertiary treatment is which process, sir? Physico-chemical process. It's a physico-chemical process. Is it okay? Right? Go for next number 23, bioremediation. What it is? Bioremediation. Bioremediation. What is the meaning of bioremediation, sir? Sir, bio means living organisms, right? Here we are using microorganisms. Therefore, bioremediation using microorganisms. Using microorganisms. Why? To remove toxic substances. To remove toxic substances. To remove toxic substances such as oil and chemical spills from water bodies, and what more, sir? Pollutants are toxic substances from soil. See these statements carefully. Bioremediation, right? Using microorganisms. Why? To remove toxic substances. Such as oil and chemical spills from water bodies. Sir, this water body, from where it got this oil and chemical spills, sir? Accidentally, if any oil or chemical is released into a water body, that oil or chemical spreads on the surface of the water body. So we are calling it as a spill. Yes or no? When oil or a chemical is leaked accidentally into a water body, that oil or chemical spreads on the surface of the water body. So we are calling it as what, sir? Spills. Is it okay? Sir, when this oil or chemical spreads on the surface of the water body, what happens? The amount of dissolved oxygen in the water decreases. Amount of dissolved oxygen in the water decreases. So aquatic animals won't get sufficient amount of oxygen. Aquatic animals, they won't get sufficient amount of oxygen. So that oil and chemical spills should be removed. To remove that oil and chemical spills from water bodies, what are used, sir? Microorganisms are used. In first year we read one scientist name by Chakravarti. He is a Indian born American scientist. Chakravarti is a Indian born American scientist. What is the speciality of this Chakravarti, sir? He developed a microorganism by name Pseudomonas putida. Pseudomonas putida. Pseudomonas putida, right? It is a bacteria. Pseudomonas putida, it is a bacteria. What is its speciality, sir? It has ability to eat up the oil. Pseudomonas putida bacteria can eat what, sir? Oil. Can eat oil. That's why the Pseudomonas putida is called as what? So it is called as oil eating bug. What it is called as? Oil eating bug. It is also named as a superbug. Therefore, who is named as oil eating bug or superbug? Pseudomonas putida. It was developed by whom? Chakravarti. Actually, we will pronounce the scientist name as Chakrabarti because he belongs to Bengal. Chakrabarti. Is it okay? Right. Therefore, Pseudomonas putida is a oil eating bug. It is a superbug which has ability to eat up the oil. Therefore, Pseudomonas putida can be used to remove, right, oil spills from water bodies. Use it to remove oil spills from water bodies. Yes or no? Therefore, bioremediation means using what? Microorganisms. Why? To remove the toxic substances. To remove what? Toxic substances. Not only from water bodies but also from soil. Right?